So what happens is, when we blink our eye, we go completely blind, but still we actually don't feel it because the image is retained by the eye for 1/8 of the second. What I mean is, when I'm blinking for a moment, if I'm blinking for more than 2 seconds, suppose I'm going like this, so I'm getting completely blind, I can't see because nothing is entering my eye. But the image which I last saw persists in the eye, or it remains in the eye for 1/8 of the second. It is actually from 1/8 to 1/15 sometimes, because it actually varies from person to person, but 1/8 is the minimum time for which it definitely retains. So let's talk about 1/8 to 1/10 of the second. Okay, now this whole thing is called persistence of vision, that eye persists the image for this small interval of time. This is the property which enables us to watch movies, because in previous days, or when the days of motion pictures, when there were newly launched technique or technology through which we were used to see videos, right? So they used a lot of images. It's like flip book. We have seen the flip book in our childhood, that when we keep flipping the pages of the book, all the images which were drawn on the pages, they come to motion. How? On the first book, on the last page, it would be a man like this. On the second last page, the hand would be raised by a little amount. Then the third page, the hand would be raised by more amount, and on the next page it will be more. So if you keep flipping it with a very high speed, you will see that the hand is slowly coming upside. So this is why when we blink our eye, this is the reason. See, when we are blinking our eye, we are persisting the vision for 1/8 of the second. So those images were moved at a rate faster than 1/8 of the second, and that's why we couldn't recognize that they are moving the frames, where they are moving the slides in the movie hall. That is what projectors used to do. That is why there were old films, long roll of films on which there were small images. So what projector used to do was, the roll was rolling, and behind that there is a light which is projecting images, but the rolling is in the speed of, so it's such a speed that it is moving the frames at more than 1/8 of the second. These days, you must have seen technology these days, the images move at 32 fps, that is 32 frames per second. In gaming they use 64 fps or 128 fps, but 128 is very high resolution image or high processing thing. But that is how moving things are were made for us to watch in the movie screens, right? By using this the knowledge of persistence of vision. So all in all, the persistence of vision is that it is the property of eye due to which the eye retains the image, or it keeps the image for 1/8 of the second at least. Okay, let's know about some of the defects of the eye. All of us have seen someone wearing glasses. So that is a very small defect in eye, due to which some rays are falling at a place which they are not supposed to fall, behind retina or before retina. So let's talk about this thing. First one is myopia. Myopia is also known as nearsightedness. This means, as the name suggests, the person cannot see clearly nearby objects. So the person suffering from myopia would be able to see clearly the images or the objects which are at far distance, but those objects which are at near distance will not be clear to him. Why? Because the rays which were supposed to fall on the retina, they are forming the image before that. So basically these two rays, they were supposed to meet at retina, but they are meeting before retina. This is called myopia. Converse to that is hypermetropia. In hypermetropia, images should be falling on retina, but they are falling behind the retina. Third one is astigmatism. Now astigmatism is a strange thing on which there is defect on this shape, that is called misshaped cornea. What happens? Light suffers different type of refractions and the focusing gets blurred. That means all the rays that were supposed to get converged on the single point, they are getting converged at different points. Light gets scattered across the retina. That means some light rays are getting focused here, some here, some here, some here. So this is called astigmatism. In healthy eye, all the rays will fall at the same point, but in astigmatism, that is because of misshaped cornea, they will fall at, or they will get focused at different points. Last one is presbyopia. In presbyopia, it actually happens due to aging. Due to aging, what happens, the power of accommodation is lost in the eye lens. So eye lens is not able to properly focus the image on the retina. So image is not focused here, image is focused somewhere behind the retina. This is called res myopia. So there must be some technique to rectify this thing. Yes, there is. Let's revise first what are the defects. First of all, normal eye, on which the rays are falling on retina. Myopia, short-sightedness, where rays are falling before retina. Hypermetropia, on which rays are falling after metropia. It is also called as far-sightedness. Lastly, astigmatism, different focus of light, like various focusing of light. Then the correction is like this. For myopia, this is, where is myopia? This is myopia. For nearsightedness, since the rays were meeting before retina, we made them more diverse. That means we used a concave lens. So that they were entering parallelly, now they are entering in a diverse pattern. That is why those rays which were supposed to meet here are now meeting on the retina because of this lens. So this is what we check when we go to an optician, that it checks what is the number of our eye, that is how much is the power of eye lens, and how much it is required to correct it. That is why we see in the optical devices to check what exactly is the eye number, right? So rays which were falling before the retina are made to fall on the retina by using a concave lens, so that the rays are now more diverse and hence more refraction takes place and they are now balanced. In the second case, the rays which are falling behind the retina, that is in hypermetropia, they are made to fall on the retina by using a convex lens. So we made it more converged so that more refraction will make them fall on the retina. Lastly, in astigmatism, it is corrected by an asymmetric lens to compensate for the asymmetry in this whole system, right? So basically, cylindrical lens of various focal lengths is used for various parts, so that all those parts which are getting focused at different points will be focused on the same point. Now, these are few points which you should remember. For myopic eye, the image is formed before retina, right? But there is a far point of myopic eye. What do you mean by far point? It is the minimum distance of the farthest, or the minimum distance on the farther side from which, if the object is placed, the rays will fall on the retina. So that it is the last distance up to which the person suffering from myopia can clearly see the image or the object, right? So again, in myopia, what was happening? The person was able to see those objects which were placed far apart, but he wasn't able to see the objects which are placed nearby. So there must be some middle distance at which the object was able to, or the person was able to see the last placed object. That point is called far point. And similarly, there is a near point in case of hypermetropic eye. A near point is the minimum distance again at which the person suffering by hypermetropia clearly sees the image. Now, how is this corrected? This is a myopic eye. Actually, what is happening? Objects, the rays are getting formed or meeting before retina, and in hypermetropia after retina, and it is corrected by using concave lens, and here it is used by using convex lens, right? Next, refraction through prism. Before moving on to refraction of prism,